Okay, for our third example, we now have a table of values for velocity as opposed to a graph or an equation. Remember, that means we only know the velocity at these specific times. So let's highlight here that our velocity is in meters per second. We're moving along the x-axis, and our time is in seconds. The first question says, what does the value of the integral from 0 to 18 of v of t represent? So let's remember that's our displacement formula. So it's change in position. So we're going to say this represents the displacement of the particle. And don't forget, we need to put units for that. And so if velocity was meters per second, then position will be meters. So in meters, and then we'll do our time interval from t equals 0 to t equals 18, and that's seconds. It's not actually asking us to find it here, it just asks what it represents. In part B, though, we're going to use a left Riemann sum to approximate. So if we only have a table of values, we're not going to be able to find the exact value of this integral, but we can approximate it. So let's write out that we're approximating this integral. And so we're doing a left sum. We can see here our difference in intervals is 3. Each one is the same. That means we can factor the 3 out. And then we have 2.3 for my first left-hand value, and then 2.7, 2, 1.3, 1, and 1.7. And then if you simplify that, you can feel free to use your calculator, you would get 33. And since we remember that this is the displacement, we know that this is approximately 33 meters. So let's make sure to put units on there. It does say indicate units of measure. On the AP test, if it says indicate units of measure, if it actually tells you that, that means they're giving you points for it. So don't skip that. It's super easy points. So the next few parts of this example are just other Riemann sums, which you should be familiar with. I want you to do part C and part D on your own. So this is a right Riemann sum, 6 subintervals, midpoint Riemann sum, 3 subintervals. Check your answers. For C, you should get 32.4 meters, and for D, you'll get 34.2 meters. Okay, let's do part E together. So we have a trapezoidal sum of 6 subintervals of equal length to approximate this integral. So remember, with trapezoids, our formula was 1/2 base 1 plus base 2 times your height. And so we're going to have that 1/2 out in front. We have 6 subintervals of equal length. That equal length is 3, so we can factor the 3 out in front as well. And then remember, when I'm looking at this, my first base 1 is that value of 2.3, and my base 2 is 2.7. But then when I go to make my next trapezoid, I'm going to have 2.7 again for my base 1, and then 2.0 for my base 2. So all those middle terms are going to get used twice. The end terms at 0 and at 18 will only get used once. And so I'm going to write it out like this. 2.3 plus 2 times 2.7 plus 2 plus 1.3 plus 1 plus 1.7 plus just a 2.1 at the end. And if you have questions about how we did that, you can look back at our 4.6 notes and remember how we did that with trapezoids only if they have subintervals of equal length. When I simplify that, I should get 32.7 meters. You should also notice this is the average of the left and the right sums. So if you took the average of B and C, you would get 32.7. The last part of this problem is F, so it asks us to find average acceleration. So remember that average acceleration is the rate of change of velocity. And so we're going to do velocity at 9 minus velocity at 3 over 9 minus 3. So that was average rate of change of velocity. So we can use our values in the table. B of 9 is 1.3. B of 3 is 2.7 all over 6. I can leave my answer like that if I want, but let's go ahead and simplify it. I get negative 0.233, and this is going to be meters per second squared. And that's because if I look at the 1.3 minus 2.7, my velocity, that was in meters per second, and then my time at the bottom is over seconds again. So meters per second, or meters per second squared. The second part of this asks for what value of t in the table is the average acceleration approximately equal to v prime of t. So this is asking for when is v prime of t equal to negative 0.233. This is really asking you about mean value theorem. And so we can always assume that velocity is differentiable. On the AP test, they'll probably tell us that it is. So it's asking for a mean value theorem between 3 and 9. And so since we did average acceleration between 3 and 9, then we know that the t is going to be between 3 and 9. You don't need to find anything more specific than that. That's okay. So thinking about how we just found average acceleration in the last example, let's remind ourselves how we found average velocity. So remember, that's average rate of change of position. So that would be position at B minus position at A over B minus A. And for average acceleration, that's average rate of change of velocity. So we have velocity at B minus velocity at A over B minus A. Those are equations that we knew back from Unit 3. So let's think about our position, velocity, and acceleration, and let's think about what these integrals would be equal to. So if I have 1 over B minus A, I'm just going to carry that along. This integral of acceleration, so the antiderivative of acceleration is velocity, and then I evaluate at B and A, this is equal to V of B minus V of A, my antiderivative of acceleration at points A and B. And so what you should realize is that's actually V of B minus V of A over B minus A. And so we recognize that this is that formula we just talked about, average acceleration. Same idea if we have 1 over B minus A times the integral from A to B of velocity. Our antiderivative of velocity is position. So we have position at B minus position at A. And notice that's the same formula we had talked about up here, P of B minus P of A over B minus A. And that's average velocity. So what this gives us is two other formulas that we can use if we want to find average acceleration or average velocity, and we would be using integrals. It depends on what formulas you're given in the problem for you to decide what you want to use. So if it asks you for average acceleration and you have the acceleration function, then maybe you want to use that integral formula. If it asks for average acceleration but you have velocity, then you want to use that average rate of change formula. And notice when I say average acceleration, that matches up with the function inside the integral, a of t. And average velocity, that matches up with the function inside the integral. And that's going to lead us to an idea of something called average value. So if I want to find the average value of a function f on an interval, so notice this is f of x on the interval a to b, I'm going to say that's just 1 over b minus a times the integral from a to b of f of x dx. So that gives me the average of f on that interval. So let's try that out. Our first question says find the average value of the function x cubed square root of sine squared x on the interval from 1 to 3. So that interval helps us set this up. We're just going to go from 1 to 3. Our function f of x is what our integrand is, x cubed square root of sine squared x. Now don't just cancel the square root and the squared, because that's actually making sure that that sine of x stays positive. It's really like an absolute value. So you're just going to type it in your calculator just like it shows, and then dx there. So that's just my integral part. The other piece that I'm missing is this 1 over b minus a. And so this is like just the width of your interval. So this is going to be 1 over 3 minus 1. If you think about averages, like an average set of numbers, you add up all the numbers and divide by the number of numbers that you have. This is the same idea. This integral is like your sum remember, like Riemann sums, and then I'm dividing by the width of my interval, which is kind of like the number of numbers that I have. And so then I just put this in my calculator using Math 9. Don't forget to divide by 1 over, or multiply by 1 over 2 here. And you would get 5.848. So it's really just about knowing that average value formula, and then it's just plugging into your calculator from there. On our next example, we're not going to use our calculators though. Let's pay attention. We're looking at the interval 2 to 6, and our function is 2 minus 4x. So we're going to go 1 over 6 minus 2 times the integral from 2 to 6 of 2 minus 4x dx. This is something we know how to take the antiderivative of, so we'll just do it directly. We've got 1/4 out in front. That just comes along for the ride. Our antiderivative of 2 is 2x. Antiderivative of minus 4x is minus 2x squared. And then we're evaluating from 2 to 6. So we have 1/4 times 12 minus 24. Oh, sorry, minus 72. Minus 4 minus 8. So we've got 1/4 of negative 60 plus 4. So that's 1/4 of negative 56, which would give me negative 14.